You made it! Our last Ed puzzle of the year. Probability of compound events. How do tree diagrams, tables and lists help you find the probability of a compound event? All right, so a compound event. All right, so like compound sentences and all that, we're going to be talking about compound events. Sample space, first word, a set of all possible outcomes in a probability experiment. Okay, so all the possible outcomes. The next word is tree diagrams, organized list tables, and these tree diagrams can be used to represent sample spaces, and you'll see what they look like in just a moment. All right, so let's take a look. A car can be purchased in blue, silver, red, or purple, 4 different colors. It can also come as a convertible or a hardtop. All right, so I want to create a way to figure out what are all the different possibilities that I could have. So I'm going to show you the first way. I could just write down as a table, right? I can say blue, blue, silver, silver, red, red, purple, purple. The reason I write them twice is because it could be blue convertible, blue hardtop, silver convertible, silver hardtop, and so on for the red and purple. So this is creating a table here. I could also create a tree diagram, and that basically says that, look, I've got blue, blue convertible or hardtop, silver convertible or hardtop, red, same, and purple, same. So in reality, the sample space, all the possible outcomes could be blue convertible, blue hardtop, silver convertible, silver hardtop, red convertible, red hardtop, purple convertible, purple hardtop. So there's 8 possible outcomes. So that's where this comes in handy using a tree map. All right, a compound event consists of 2 or more simple events. So let's take a look. Suppose you toss a quarter and a dime and a nickel. Find the sample space and what's the probability of getting all tails. Okay, so there's 3 coins, quarters, dimes, and nickels, and this is what I would expect to see from you from a tree diagram. So the quarter, there's only 2 possibilities, heads or tails. Okay. Then I'm going to go ahead and add another compound event. I'm going to say, well, what about dimes? Well, I could, on the dimes itself, I could have a head or tails. The reason I'm going to write that twice is because what if I got a quarter, heads, dime, heads, quarter, heads, dime, tails, right? Or quarter, tails, dime gets the heads, quarter, tails, dime gets the tails. So those are the 2 possibilities, and here I'm going to have to write it twice because it depends on these 2. Well, you can see here in nickels, my last one here, I could have it as after I flip the quarter, after I flip the dime, now it goes the nickel, and for each one of these, there's 2 more possibilities, right? So heads and tails, heads and tails, heads and tails, heads and tails. So the sample space is given over here. I just used letters. I could choose all heads, right? Quarter, dime, and nickel, all heads. I could do heads, heads, tails. Heads, heads, tails. Heads, tails, heads. Heads, tails, heads. Heads, tails, tails. That's this. And you can see listing on there. So total number of sample spaces is 1, 2, 3, 4, 5, 6, 7, 8. There's 8 in the sample space. And the favorable outcome, the one I was looking for, was all tails. So the probability of 3 tails is a 1 out of 8 chance, which is a favorable outcome. The favorable outcome was the 3 tails I was looking for. So that's my probability, and you can figure out the percentages and such. All right, that should give you enough information to finish up your classwork and homework. Be ready with questions. Tomorrow we will start our review for the final, so make sure you come prepared.